we are going to do the functions, the topic that we call functions. Functions. Right, we've got the following functions. There is the one that we call it a linear function. A linear function is a straight line. Right, the other one, we call it a quadratic function. The next one, let's go to hyperbolic function. And then a quadratic function, exponential. Right, all these functions have their inverses. Each of these functions, they've got their inverses. For now, let's look on what we call a linear function, which is a straight line. Right, a straight line. A straight line is given by g at x equals mx plus c. When we talk of a straight line is formed by 2 points. If you have, for instance, the 2 points like that, it's point A and point B. So joining the 2 points, when you are to join the 2 points, they form a straight line. So a straight line, it can be horizontal or it can be on an incline. It depends. So that means for a straight line, you'll have to find the gradient so that you will tell the slope of that function. Therefore, here we've got g at x and x. X and g at x. So this is a given point. It's a given point or any point. This is a given point or any point in a graph. And then again, we've got m. M represents the gradient, the slope of the graph. M represents the gradient, and then we've got also C. Right, when you look at C, if you are to let x to be 0 here, you'll be left with C, which means C is the y-intercept. C is the y-intercept. Right. As we have mentioned, this is an equation of a straight line. It's a standard form, this one. There is this one again, y equals, or it's y minus y1 equals m into x minus x1. Again, this is the equation of a straight line. It's the equation of a straight line, where m is the gradient, Normally, we use this in most cases where we talk of a tangent. A tangent is a straight line. So y and x, again, this is a given point. And then we've got x1, y1, x1, y1. We usually call this point of contact. This is the point of contact. And then m is our gradient. Right, let's say you have this equation. It's simple. For a straight line, you just need 2 points, as I've indicated there. You just need 2 points, and then you join the 2 points. So, if you are being given this equation, for instance, g at x equals 2x plus 2, like that, and you are to sketch this graph, you need to find only 2 points. Only 2 points, x-intercept and y-intercept. Because it's a straight line, you just find 2 points. And then for y-intercept, always we make x to be 0. So if you let x to be 0 there, this will become 0 equals 2 times 0 plus 2. Therefore, this is equal to 2. That's the y-intercept, which means our y-intercept will be given by 0 is to 2. Let's find the x-intercept. For x-intercept, we let y to be 0. We let y to be 0. Therefore, here it's 2x plus 2 equals 0. Our y is 0. 2x will be equal to negative 2. You are transposing 2. Therefore, x will be equal to negative 1. The x-intercept will be negative 1 is to 0. These are our 2 points to sketch a graph. Our 2 points to sketch a graph. It's negative 2, negative 1. It's 0 there. It's 1, 2, 1, 2, negative 1, negative 2. Right? You simply have to indicate the 2 points and join them since it's a linear. Negative 1 is to 0. Negative 1 is to 0. Y is 0 here. And then 0 is to 2. It's up there. And then you join the 2 points. Just join the 2 points. This is the function of g. With the points 0 is to 2 there. And here negative 1 is to 0. That's how to sketch a graph. It's simple. You just have to find the 2 points. Right. Let's see now when we have this graph. F at x is equal to negative 2x minus 2. Negative 2x minus 2. Right? our y-intercept, y equals mx plus c. So our y-intercept is that. Our y-intercept will be 0 is 2, negative 2, because you just let x to be 0. And then for x-intercept, we let y to be 0. It's f at x to be 0. Therefore, negative 2x minus 2 will be equal to 0. And then we transpose negative 2. It will be minus 2x equals 2. We divide by negative 2 on both sides. Therefore, our x will be equal to negative 1, which means the x-intercept will be negative 1 is to 0. Let's sketch this graph. Let's sketch it. Negative 2, 1, 2. Right, let's look on our y-intercept. Our y-intercept is negative 2. And then the x-intercept is negative 1. Y-intercept is negative 2. Our y-intercept is negative 1. And then we join the 2 points. That's how our function will be looking like. So comparing the two functions, this one here, the gradient is positive 2. The gradient here, it's positive. It's plus m. When you go up, the gradient is positive. But then here, since the gradient was negative, that's the reason why we are having a decreasing function. Our function will be decreasing since the gradient was negative like that. So let's see on how to find the equation of a function if you are being given the graph. Finding the equation. Right, finding the equation when you are being given a graph. Let's say this is the function you are being given. Right, that's what we have. Let's say this is the function of h. And then you are being asked to find the equation here. This is what it's been given. So for you to find the equation, remember that the equation here, it has to be in this form, in a standard form, h at x equals mx plus c. Therefore, we've got the value of c, which is our y-intercept. We do not have the gradient. In other words, we need to find the gradient first. So the gradient that you will be finding here is the average gradient, which is given by y2 minus y1 over x2 minus x1. So you can name your points. It's either this is 1, 2, or 2, like that. So let's use this as 2. So it's y2, which is 3 minus our y1 is 0. Again, remember it's 2 here, it's 1 this one. Therefore, 0 minus that. It's 0 minus negative 2. 3 minus 0, it's 0. It's 3. 0 minus negative 2, that will be positive 2. That's our gradient. Therefore, we can now write our equation because we've got the value of c. C is the y-intercept. Our intercept is there. Therefore, h at x will be equal to, our gradient is 3 over 2. It's 3 over 2 in the place of the gradient, and then we put x as it is. Our y-intercept is that one, which is plus 3. So the most important thing is that your equation has to have y and x, and then the numbers. We do not need m. If there is m, find the value of m. If there is c, find c, so that you are going to be left with y and x. That's our equation. That's how to find the equation if you are being given the points on a graph. Right, from our first graph, the graph of G, it was like this. This was 0 to 2. Right. Let's now find the inverse. It's g at x equals 2x plus 2. That's the equation of this graph. So let's see how to find the equation of the inverse of this graph. The inverse, right. The inverse is where we are going to swap x and y. In the place of x we put y, in the place of y we put x. That's how to find the inverse. Where there is y, we put x, where there is x, we put y. Let's see. We've got g at x equals 2x plus 2. Before you swap the points, write this in a form y equal to. So this will be y equals 2x plus 2. And then we swap x and y, which means we are going to start with x now. It's x equals 2y plus 2. This is the inverse. It's the inverse. You've just swapped x and y. This is the inverse. Let's sketch this graph. X is equal to this. Let's sketch the graph. We just want to compare the two. Right. Remember that for us to sketch a graph, we need x and y intercept. This is what we have there. It's a 2y plus 2. So for x-intercept, we let y to be 0. So if you let y to be 0, therefore the x-intercept will be 2 is to 0. The x-intercept will be 2 is to 0. And then now let us find the y-intercept. For y-intercept, we just let x be 0. 2y plus 2 will be equal to 0. 2y will be equal to negative 2. Therefore, our y will be equal to negative 1. Therefore, our y-intercept will be 0 is to negative 1. So we've got the 2 points. We can now draw a straight line. Remember that our y-intercept 2 is to 0. 2 is to 0. There is the point. Y-intercept 0 is to negative 1. 0 is to negative 1. Right, that's the inverse. So to indicate that it's the inverse, you need that side. If it's g at x, the inverse will be like that. That's the sign that indicates the inverse. Right. We've got this point, which is 0 is to negative 1. Here we have 2 is to 0. Let's come back here. I said for the inverse, we just have to swap the points. So when you look here, if you are to swap the points, you are going to have 0 is to negative 1. Again, there, if you are to swap, you are going to have 2 is to 0. That's the reason why now here we are having this kind of graph. This is the graph of the inverse. The inverse of g at x. It will be looking like that. It is still increasing. The shape doesn't change. It's still increasing. The only thing is that you are to swap the points. You do not change the gradient, the slope. It is still going up, but the only thing is that you just swap the points. Right. This was our inverse. It's the inverse of this equation. And then if you were being asked to find the equation of the inverse, that's where you are going to make y the subject of this equation. That's the equation of the inverse. If it's like that, x is equal to, this is the inverse. But once you make y from the inverse, once you make y to be the subject, we call that the equation of the inverse. Let's see. It's 2y plus 2 is equal to x. And then we transpose 2. 2y is equal to x minus 2. We divide by 2. Y will be equal to x minus 2 all over 2. We just divide by 2. This will be written as y equals it's x over 2. Here it's x over 2 minus 2 over, it's 2 over 2. 2 over 2. X over 2 is the same as 1 over 2 times x. So this will be 1 over 2x minus 1. This is the equation of the inverse. If you are being asked to leave it as y equal to, leave it there, but then if you are not being asked to do so, you go back to indicate that it's the inverse of G, you indicate it like that. This will be 1 over 2x minus 1. It's 1 over 2x minus 1. That's how to find the equation of the inverse if you are being given that. Right? The most important thing again is that the gradient remain positive. The gradient remain positive. What we have to notice in terms of the gradient is that here we've got the gradient which is 2. The gradient of that function is 2. So we are talking about the inverse. So the inverse of 2, it's 1 over 2. The inverse of 2 is 1 over 2. That's the reason why we are having the gradient which is 1 over 2. I think this is all what we need in terms of a straight line. We are going to stop here for a straight line.